Hello, this is ninth video on my channel. Let's discuss other problem. It is the apple harvest season. Alice and Bob are all set to pluck them from their farm. However, due to a certain incident, the apples are now falling down one from another. The farm in an infinite large 2D plane. Given the initial coordinates of Alice and Bob, and also the coordinates where n apples will fall, you need to calculate the minimum Manhattan distance covered in total by Alice and Bob together in order to catch all the apples. The Manhattan distance between two coordinates is sum of absolute of x coordinates plus absolute of y coordinate difference. It can be assumed that they can reach all distances without letting any apple fall down to the ground. Also, you need to help them catch apples in the sequence they fall. That is, they should catch the first apple and then next the second one and then third and so on. And coming to constraints, n can go up to 1e3, and as it is given that the 2D grid is infinite large, we can assume that the coordinates range from -1 in n to 1 in n. And there are some apples. By optimally, they can start picking the Alice can start apple 1, then any of them can go to apple 1 and then go to 2 and so on, but they should collect all the apples in the same order in the given way. So if there is a function which returns the answer for the optimal answer when Alice is at coordinates xay and Bob is at coordinates xbyb, and the apple we should collect now is index. So if Alice picks the present apple, the distance he need to travel is distance between his present coordinates and the apple that is to be collected, and the new function is the coordinates of the new apple, and the Bob did not walk in this period, so the same coordinates as before, and as we collected the apple at index, the next will be index plus 1. So similarly, if Bob decided to take the present apple, the distance he need to travel is the difference of the distance between Bob before position and apple at index. So Manhattan distance of that plus the next function will be the Alice did not walk during this period, so he will remain in the same coordinate as before, and the Bob's coordinate are now at the new apple, and then as we collected the present index apple, the coordinate of the index of next one will be index plus 1. So by observing this, we can try to get a DP state where it is a 5-dimensional, and the first two represents coordinates of x Alice, and the next two represents the coordinates of Bob, and the next one indicates the apple that we are going to collect now. As this will surely not pass, let's try to optimize this. Before going to discuss, let's try to think in a different manner. For example, there is a kind of bell which will ring after some time after picking some apple. So initially Alice and Bob are at AB and apples are at A0, A1 and A2, and now the bell rings. So they have to decide, and if they decided to move Alice to the first apple, then Alice will go, else Bob. So if they decide to send Alice to the 0th apple, now Alice is at A0 and Bob did not travel during this transition, and next after some time the bell will ring again. Then they will decide Alice or Bob to go to the next one. If they decide that Bob should go this time, the Bob new position will be A1 and Alice's old position is same as now, which is at A0. And after some time similarly the bell rings, and then they will decide, and if they decide to go with Alice this time, so he will go to the new position which is A2 and the next apple to be collected, and Bob will be at the same index before, which is at apple 1. So, and similarly the cycle goes on. From this, if we try to observe that the positions of Alice and Bob are only few, whether they can be at the initial positions which are given, or they will be at any apple that they have collected before. Because for example, in the given state, initially they are in these coordinates, and after collecting first apple, the coordinates are initial or the first apple, and after the second one, collecting the second one, the Alice is at apple 0, the Bob is at apple 1, and after collecting the third apple as well, the Alice is at second index apple and the Bob is at first. So we can understand that The positions of Alice possible are initial given possible value of A or any of the apples collected at last. Similarly, Bob, so the values of coordinates of A and B are fixed and limited to only n plus 1 cases where n is the possibility of apples and 1 is the initial position. So we can just try to remove these coordinates because we have seen that they will be in the initial given coordinates or any one apple. So it is enough to store a number here which represents the apple they are landing on. So we can try to optimize the first two coordinates to A and second two to B and the third one remaining B, where A is the apple position where Alice is at and B is the position of Bob and index is the apple index from where we are collecting now. But the values of AB index all are limited to 1 in 3 and the total space complexity will be 1 in 9, which is not possible to store. So let's try to optimize this as well. A and B are similar because both are indices of apples where Alice or Bob are presented now and the index is the apple we are going to collect now. Let's try to optimize, let's try to remove Alice or Bob and let's find whether it is possible to find the answer or not. So for example, if we try to remove Alice, then the function will have only the parameters, the Bob position and the index that we should collect. But surely we are not able to find the Alice coordinate and it is not possible to find the distance traveled by Alice to collect this. So we are sure that we must need the positions of Alice and Bob to find the answer. So let's try to remove index now and try to find how can we achieve this. And the next problem is, now we have reduced the 5D to 3D, but now even as well we discussed that the Alice positions are initial or any of the apples, but we have directly replaced with index. So how can we maintain this? So we can assume that if the value of A, this A is 0, it means that Alice is at the initial given position and he is not landing on any apple. If A is equal to 1, it means that he is at apple of index 0. We are just assuming this because we have to maintain all the given information of Alice only in this single state. So if this is A and it is equal to 0, it means that he is not on any apple and he is initially at the default coordinate. If it is equal to 1, it means that he is at apple 0. If it is 2, he is at apple 1 and so on. So 0 is the initial position, the 1 is at apple and index is 0 and 2 represents that he is at apple which is at index 1. And similarly the same for Bob. If B is 0, it means that he is at the initial given coordinate and if it is 1, he is at 0th index apple. If it is 2, he is at first index apple and so on. So let's discuss how to optimize other state. So for example, let's take several values of A and B. Let's find what is the value of index. For example, if both are initially at their given positions, this means we have not collected any apple yet till now. So what is the coordinate, what is the index of apple that we are going to collect from now? It is 0 because both are at 0, which means they are at given initial positions and they are not at apples, so they have not collected any apples. So the index is 0 now. And for example, if the DP 0 and 1, Alice is at initial given position and Bob is at 1. What is 1? Apple at the given 0th index. So if DP 0 and 1, then what is the index of apple we have to collect? It is 1 because Bob is at 1. So he is at the 0th apple. So next apple to be collected is 1. Similarly, if Alice is at 1, which means he is at the 0th apple and Bob is at 0. This means he did not collect any apple so far. So the index of apple that to be collected now is 1 because Alice collected 0th one. And similarly, if it is 1 and 2, Alice is at 0th apple, Bob is at first apple. So we have to collect the second apple. So index is 2. Similarly, if Alice is at 0th apple, Bob is at second one, we have to collect from 3. So it is 3. From this, if we try to observe one thing, the index of apple that we are going to collect now is maximum of A comma B. The maximum of values of A comma B. Why is this? Because if they are collecting apples now, they will be surely in any of the apples position or initial. As we discussed that initial is taken as 0, obviously the maximum of both is the last they have collected so far. So for DP of 1 3, Alice is at 0th apple, Bob is at 2nd apple. So we have to collect apples from 3rd index. So the index is 3. So finally, with only A and B, we are able to find index. So we can successfully reduce another state. So let's check the code. We are initially taking the number of apples and initial coordinates of both. We are taking the coordinates of apple and storing in the apple vector. Apple of I indicates the coordinates of ith apple, and we are initially making the values of dp as -1, and we are printing function of 0 0. This means that both are at given initial positions and they have not collected any apple so far. And coming to function, as we discussed that the index of apple that we are going to collect from now is maximum of Alice and Bob. So int ind is equal to max of Alice and Bob. And if we have collected all the apples, so if index is greater than or equal to n, there are no apples to collect now. So return 0 as we have completed the given task. And if dp of the state is not -1, so this is already pre-computed earlier. So we can just return this. And now coming to the cases where Alice is going to take the present apple. So if Alice is trying to take the present apple, the distance traveled by him is Alice distance of the Alice current position and the index plus the function of index plus 1 Bob. What is this? The Alice is collecting the apple now. Alice is collecting the apple at index. So based on our one based indexing, he is collecting apple at IND index. So A will be index plus 1. So he is collecting the apple at IND index. So the A regarding him will be index plus 1. So similarly, if Bob is going to take it, the total answer is distance traveled by him to collect the apple and function of Alice and index plus 1. So finally, we are returning the answer as minimum of both distances. So what is Alice distance? So int A and D index. So A is 0 if he is at initial position, and if it is not equal to 0, it is at that -1 index apple. So initially answer is 0 here, the distance is 0, and the coordinate of apple, the x coordinate of apple is apple of index, and apple y coordinate is dot second. If A is equal to 0, he is at initial position. So if A is equal to 0, we are returning the Manhattan distance between his initial coordinates xa ya and the apple that we are collecting now, apple x and apple y. And if he is not at initial position, he will be at a-1 index apple. So the its coordinates are old apple x and old apple y. So if he is not at initial position and if he is at any apple index positions, the answer will be Manhattan distance of these both. So similarly, the distance of Bob, old apple x and old apple y, and if b is equal to 0, he is at initial position. So Manhattan distance between the initial coordinate and this present index coordinate. And similarly, if it is not, the Manhattan distance between these both. And finally returning the answer. So in this way, we can try to optimize the given very big DP state into 2D DP, and the time complexity and space complexity are 1e6 because the state now is only 1e3, 1e3. Drop a like and comment below. If you have any doubts, post in the comments below. See you in the next video.